Today's focus is going to be comparing endothermic to exothermic reactions. So with this concept, it is very important for you to understand two main ideas. First off, it takes energy to break bonds. Secondly, energy is released when new bonds are formed. So how do we figure out if a reaction released or absorbed energy? All we need to do is compare the energy required to break the bonds initially and to the energy that was released when these new bonds were formed. I personally like looking at graphs, okay? So for an exothermic reaction, first off, you want to look at what exo mean. I always think of an exit sign. So an exit is leaving. So an exothermic, and therm means heat. So what an exothermic reaction is, heat is leaving the system, okay? So if I look at my graph on this, I look at my reactants and how much energy it had initially and how much energy it had in the end. And if I look at it, I went down in energy, which means my energy was released. So this would be an example of an exothermic reaction. Now comparing my bondage and my bond's energy, which I talked about on the previous slide, the energy used to break those bonds was more than the energy required to make the new ones. As you could see, the energy required to break those bonds was greater than the energy required to make the new ones. That's why it went down in your graph. Endothermic, on the opposite, is the exact opposite. So instead of the heat leaving, heat is entering, or energy is entering the system. Okay, so the energy needs to be absorbed by the system. Graphically, what it looks like is I would have my energy for my reactants, which is lower than my energy of my products. In order to transition from my lower to my upper, I'm obviously going to need to absorb this amount of energy, which means I would have an endothermic process. Now, in order to understand this, as far as the breaking and the making of bonds, the energy used to break the bonds, which is your initial, is less than the energy required to make your new bonds. That's what this guy right here is translated into a graphical form. So in order to be able to truly identify what is an exothermic and an endothermic process, it is very important for you to understand these two terms. One is a system, the other is your surroundings. The system is whatever you are currently studying. The surroundings is everything else. Okay, so the system is what you're truly focusing on. The surroundings is everything else. So if I wanted to see if a hot pack is exothermic or endothermic, the hot pack itself, which is what I'm interested in, would be my system, and everything else but the hot pack, for example, your hands or the air or a table that it's sitting on, would be your surroundings. So we also can't observe the bonds breaking or being formed. So what we do is we try to compare the energies before or after. And that's where you look at your endothermic and your exothermic processes. If your surrounding temperature decreases, that is an endothermic process. Why? If this is my system, okay, and this is my surroundings out here, okay, let's say this is my surroundings, and the surroundings temperature decreased, okay, what that means is that my system is absorbing that energy that my surroundings just gave up. Okay, so I would notice that the surroundings temperature decreased, but my system actually would increase its amount of energy. Notice that it is absorbing it. Exothermic, the surroundings temperature would increase. So if I have, like, let's say I'm studying a hot chocolate mug, okay, that's a really great mug, okay, and my surroundings increased, which means my temperature is increasing for this surroundings right here. What is happening to my hot coffee or my hot chocolate? It is going to be losing or releasing that energy. Therefore, this coffee would be an exothermic process. So let's try to label each picture as an endo or an exothermic process. Now we are focused on, in order to do this, we need to identify what is our system. Our system is going to be whatever that liquid is in that substance. So, or whatever that liquid is in the beaker. So what is happening to that liquid? Right now, that liquid is getting energy added to it. That means it would be an endothermic process. Whereas this guy on the right-hand side is releasing its energy, so it would be an exothermic process. So on the left side, my process is increasing its temperature, and therefore it is absorbing that energy. On the right-hand side, it is decreasing its amount of energy, releasing it, therefore it would be an exothermic process. Identify each reaction as endothermic or exothermic, and we got to calculate the change in temperature. So if this is the outside temperature, okay, and then it goes from 32 to 27, where did that heat go? Did it go into it or out of it? Well, in order for the temperature on the outside to go down, my energy needs to go away into the system. Okay, so this guy right here would be going, it would be changing 5 degrees, but the reaction that I care about is the one in the beaker. So what is happening to it? Well, the arrows are going into it, so therefore it would be an endothermic process. The surrounding temperature, notice, decreased by 5 degrees. On the other hand, if I go from 22 degrees to 27 degrees, my increase in temperature is 5 for the outside, which means that somehow I had to gain energy on my outside in order to go from 22 to 27, which means that this guy in here in this beaker is releasing that energy. Therefore, the process in the beaker is an exothermic process.